Hello, I am Luis Gabriel, and this is the evidence of the project circuit of analysis of electrical circuits. First of all, here's a context of the problem. In February of 2019, the leader of the Chamber of Industry and Transformation in Mexico started that the CFE and the federal government cannot satisfy on their own the country's energy supply and needs due to the large population growth and economic development. Additionally, before indicating the CFE should have to increase their investments 8 times by 2022 in order to satisfy such demand. They complemented that if we do not act quickly and if the federal government does not call entrepreneurs, investors, and regulators such as CRE for a collaborative effort, in 3 years we might experience a shortage in electricity supply and periodic outage, which will be devastating for Mexican economy. In summary, the problem is that Mexico faces challenges in meeting its growing electricity demands, despite the significant potential for solar energy production. To address this, it is essential to understand the current situation of photovoltaic electricity generation in the country, along with the basic principles of how photovoltaic systems operate. Additionally, the use of measurement instruments to analyze voltage current characteristics in photovoltaic modules connected in series and parallel is crucial. Identifying factors that affect the performance of these systems will also help optimize their efficiency and contribute to a more sustainable energy solution for Mexico. Here is a little demonstration of the cell characterization. With a little help of a multimeter, we were able to determine the measurements of the voltage power to our solar cell produce, showing the highest and the lowest point of the voltage power. As you can see in that plot, the voltage decreases slowly with every value of the current. Here's the demonstration of the electrical circuit at daytime, because during the daytime the electrical circuit generates power that flows through the circuit. The element that is in charge of providing current in only one direction during daytime is the diode. The diode is a special component of the circuit that protects other components of receiving current that they don't intend to receive. The current that flows through this diode during daytime then flows through the transistor, and the transistor works as a door that opens and closes many times per second, and it also depends on the transistor state. Whether it flows or not flows current through the MOSFET. That is our next special component. The MOSFET of the N-type MOSFET is another kind of transistor. It is in charge of conductivity, and it controls the flow of the current and the voltage between the source and the drain terminals. If the MOSFET state determines that the current can flow through it, the current flows along the circuit passing through their resistance with their 10,000 ohms and 100 ohms protect the other components of a high quantities of current and voltage. But this does not happen in the daytime. The transistors stay during the day almost at every time in an off state. And to summarize what is happening in the circuit during daytime is that the diode at first receives power from the solar cell and it conducts current in all the direction, that is, into the circuit. The transistors, depending on the state, and this case being in an off state, do not allow that current pass through them. The resistances take care of protecting the other components of dangerous quantities of power. And finally, the purpose of the circuit is to recharge the 3.7 volts battery with the power created by the solar cell to then pass to the next stage, that is the nighttime. And here is the demonstration of the electrical circuit during the nighttime. Here, the first thing that we can notice is that the solar cell becomes inactive. The main purpose of the solar cell is to produce power with the help of the sun, with the energy of the solar rays. Thanks to the power of electricity created by the solar cell during the day, the battery recharges it and it recharges into the maximum capacity of the voltage. Then, during the nighttime, the battery is the one responsible for providing power into the circuit, and everything becomes the opposite. The voltage that was picked up by the battery during day flows through the circuit as power and gives power to the diode. Then the special components that are the two transistors switch into an on mode that allow current to pass through them. That current and the power that passes through them then passes along their resistance that finally delivers a power to the LED light that turns on bright when this process is completed. Basically, the functioning of the circuit during nighttime is the opposite of the functioning of the circuit during daytime. The battery is completely recharged thanks to the power created by the solar cell during daytime, and the battery provides the power up to the circuit, and with the help of the transistors, the LED turns on. Now here is a demonstration of the implementation of the circuit. Here we can see how the LED light turns on when we put our hands on the cell, and it turns off when we take it off. And here are the values that we obtain of the day and the night, also counting with the theoretically values, and then the experimentally values that we obtain in real time. So first we obtain these plots. The first plot is about the theoretical data. In this plot we can see the calculated voltage of the different elements. We can see we can see that the highest voltage there is the voltage of the resistance of the 10,000 ohms at night. At the point the LED light is active, meaning that the 10,000 ohm resistance is getting its maximum voltage potential. And in the experimental plot, we can see that the LED at night and the resistance remains as the elements with the highest voltage. In this case, the LED is the one with the highest due to the fall of the voltage of the resistance in real life. Now, this is a comparison plot about the two plots before, the day and the night, and it's both theoretically and experimentally data. Taking into account that our diode had a fall of 0.7 volts, we can measure more accurately the current in the resistance of 10,000 ohms using a voltage of 4.7 volts that we found because of the equation 5.4 volts minus 0.7 volts equals to 4.7 volts. The voltage fall between the LED and the resistance is around 1.4 volts and 1.6 volts. In our case, it is a white LED that produces a voltage fall of 1.4 volts. And finally, during the construction of this specific circuit while analyzing its components, we were able to observe in more depth the correct functioning of the physical capabilities of the components of this circuit. The most surprising thing was the reaction of the LED with the use of the photovoltaic cell and how it managed to work. Within all this, we can highlight the importance of current and voltage, since the calculations, these values are really important for the construction of any electrical circuit. Furthermore, the comparisons between the two sets of data showed us that the voltage and current of the circuit did change noticeably, so this is a perfect evidence when making the graphs and their interpretations. That will be all. Thank you.